Good morning or good afternoon to everybody. My name is Antonio Lecuona, and I am going to present this paper, second generation solar air heater for passive dryers with sensible heat storage. Normally, in a classical view of that, drying food and other agricultural products is performed in open air, either under the sun or in the shadow. But this practice needs great care because otherwise the quality of the food can deteriorate very much, and also the safety of the consumers is in danger. So other possibilities must be studied. Another possibility is burning fuels for drying the product, but this consumes much energy because of the high enthalpy of evaporation of water, and this can derive in local deforestation when firewood is used for that, and also to quality reduction because of the smoke or perhaps overheating. This way, we need also other possibilities, especially for in situ drying. In situ drying is needed because normally uh, families and small communities that are isolated or remote, they harvest and they cannot consume all the products. So there are many post-harvest losses and as a consequence, an energy poverty. Solar drying is performed in several ways, and one of the most fastest ways of drying is the indirect solar dryers, where you can see here one example. It is controllable and also it is relatively well known. It consists on a solar air heater that heats air using solar energy, and this air spontaneously flows upward in the downstream cabinet where the food is stored. The food normally is spread in trays so that drying is homogeneous. Mm, This way of drying is what we call passive dryers, and it avoids any electrical hardware and also any electricity consumption. The problem is that the inner air draft is slow. This is not good for increasing the speed of drying, but in some way it has some advantages. For example, it is self-regulated because as more solar radiation impacts on the solar collector, there is more induced velocity because of the buoyancy of the air, thus limiting temperature. This kind of solar dryers are cheap and simple, and they can be manufactured locally in situ and even maintained and repaired in those places, this way enhancing the energy independence. But still, there are some problems, especially during the nights and during cloudy periods, because drying almost stops. And also, some condensation of humidity can ruin the food, so that there is a solution. And the solution here proposed is thermal energy storage, or TES. With this way, a mass is heated during the day, storing thermal energy, and it is cooled during the non-illuminated periods. This means nights and cloudy periods, and this way drying continues, and some of the dangers are avoided. This is our contribution. It's a second generation solar air heater for passive dryers with sensible heat storage. What does mean? This means that we concentrate our study only on the solar air heater collector, not in the cabinet, because we find that we can implement there the thermal energy storage that in our case we decided it to be sensible. Why? Because of cost, because phase change materials are expensive and their duration is not ensured. We have studied this configuration both theoretically and experimentally in order to obtain detailed information for others to apply this knowledge and to continue enhancing it. In this photograph, you can see on the left side the stars where they indicate the points where we measure. On the left side and on the right side, they both join and mix together, and they are evacuated by a chimney. Also, we measure the inlet air velocity. Also, you can see in this image two measurements that have been performed in the chimney. The chimney is for enhancing the draft velocity and also to avoid or reduce the effect of wind gust in the functioning of this natural draft solar air collector. Here in this image you can see the nozzle, that is a reduction in the area that you can see here, where we perform also measurements, and there is a transition towards the round chimney that is made of commercial elements. On the right side you can see the cans, the aluminum cans for refreshment and beverages that are used completely filled with the content to make the thermal energy storage here. As you can see, they are painted black, in order to operate as the solar absorber. On this image you can see the transparent cover over the cans, and this on the right side you can see the general cross section of the air, the space for the airflow, and also how the cans are located there. Well, this solar air heating collector this way can be constructed in remote and isolated places because the transport of the cans is easy and they are cheap and they can be procured in almost all the world. Let me show you some of the experimental results. These results correspond to July the 17th of 2021. On the left picture, you can see with continuous line the temperature of the cans. In blue, the lower ones, in green, the medium ones, and in orange, the upper one. And with the same colors, the temperature of the air, that is for sure lower. And you can see in yellow the temperature at the chimney, so it is very similar to the outlet temperature of the air coming out of the cans. And in violet you can see the temperature of the back plate of the solar collector, and in blue the inlet air temperature. As you can see here, the decay of the air temperature is very slow, so that during midnight you can still have drying and also an insurance against water condensations, because if we didn't have the thermal energy storage, the cooling will be very rapid. So at 8 or 9 in official time in the afternoon, it will stop. But using these cans, you see that the temperature will be quite high at midnight. There is the peculiarity that these temperatures are higher than the ones of the previous day, because the previous day was cloudy. On the right slide, you can see the solar irradiance along the day. That is, it was a sunny day. Also, this line depicts the point where we have done a 1D modeling. And why at this time? Because at this time we have the maximum temperature both of the cans and of the air, so that at this time there is no more thermal energy storage, neither any de-storage of the thermal energy of the cans. So in this point we can apply a steady state energy balance for extracting all the heat transfer that occur inside the solar air heating collector. And now let me explain you some conclusions. Implementing the thermal energy storage in a solar air heating collector can be easy, as here demonstrated, low cost and very effective. The 1D model that we developed, tuned with the experimentation, indicates the second generation solar air heating collector performs better than the first one. There are still some improvements possible, such as increasing the contact surface of the cans with the air. In the paper, in the full paper that in the proceedings should be, you can find more details on both experimentation and the theory. Now, let me thank you your attention, and of course show you a book that I have written, and you can get it for free using this link and this password. Also, I have written another book on solar cooking, but it's in Spanish, and you can also get a free PDF of the book using this link and this password. Thank you very much.